Hello students, today we are going to study about pointer basics in C programming. So a pointer is a variable that points to or references a memory location in which the data is stored. It contains the memory location of another variable. Unlike other variables that hold values of a certain type, pointers hold the address of a variable. For example, an integer variable holds an integer value. However, an integer pointer holds the address of an integer variable. Let us see a program. In this particular program, we have a variable called num and a pointer variable called ptr. So dear students, there is a way of differentiating a normal variable with a pointer variable, that is by the asterisk sign, that is the star. So here we wrote num equal to 10 and then ptr equal to ampersand num. As soon as we write this line, it means that the variable ptr, that is the pointer variable ptr, holds the address of num. Now, if we are printing the value of num, of course 10 will be printed in this line. Then, if we are printing the address of variable num and we try to print ampersand num, the address of num will be printed. Again, if we are trying to print the value stored in pointer ptr, we print only ptr. So if we are printing only ptr, it will print the address, the memory address or memory location where we have stored num. And lastly, if we are printing star ptr, it prints the value of num, that is 10. So how will the compiler read this? It will be like the value to which this ptr is pointing to, that is 10. The general syntax to declare a pointer is data type star variable name, where data type denotes the variable data type being pointed to and asterisk denotes a pointer. Pointer operator can be represented by a combination of star, that is asterisk, with variable like in star ptr. The base type of the pointer defines which type of variable the pointer is pointing to. That means if we are writing in star ptr here, it means that ptr is a pointer variable which will point towards an integer data type variable. The number of bytes required to store particular data item will vary from machine to machine. But the size of pointer, irrespective of the data type it is pointing to, remains the same. Let us see another example. So here int star ptr says that ptr is a pointer variable which can point or which can store the address of any integer data type. So after that, if we are writing int I equal to 10 and following it with ptr equal to ampersand I, it will mean that the pointer variable ptr stores the address of the variable I. This diagram will make it more clear. We can see that I is the integer variable. 1 is the value stored in variable I. This value here is actually the address assigned to variable I. And ptr holds this address. Ptr is a pointer variable which holds this address. In this particular value, you find that we have printed two things. One is star ptr, one is ptr. So again students, star ptr will actually print the value which is present in ptr that is 45. And PTR will print the address which is stored in the pointer variable. Now let us see some basic pointer arithmetic. So there are a few rules which we are going to follow when we are studying pointer arithmetic. The first one is star PTR1 equal to star PTR plus star PTR2. This means that you are dereferencing both the pointers and adding the values stored at the memory locations they point to. Afterwards, that sum will be assigned to the location pointed by PTR1. Let us see an example related to that. Here we can see A and B are two integer variables and PTR1 and PTR2 are two pointer variables which contain the address of A and B. In the next line, we wrote star PTR equal to star PTR1 plus star PTR2. So as already explained to you in the previous slide, star PTR1 will mean the value of the variable whose address is stored in PTR1. So whose address is stored in PTR1? A's address. So what will be the value of star PTR1? It will be 5. And what is the value of star PTR2? Similarly, it will be 10. So this value to the right hand side of the assignment operator equal to will be 15. So star PTR1 equal to 15. That means the value of A will change to 15 now. Let us go to the second example of pointer arithmetic. Here we are adding 10 to star PTR1. Again, let us see an example. So A equal to 5 is the variable here, and the address of A is stored in PTR1. So when we are doing star PTR1 plus 10 in the next step, actually star PTR1 again means the value of the address or value of the variable whose address is stored in PTR1. Whose address is stored in PTR1 now? A's address. So star PTR1 actually will be 5. So it is like the right hand side is 5 plus 10 which is equal to 15. Let us go to the third example. Sum plus equal to star PTR2, which means sum equal to sum plus star PTR2. Let us see the example again. Let us go to the third statement inside void main, which says that sum equal to sum plus star PTR2. Star PTR2 here will be again 5. So sum equal to sum plus. So sum equal to 20 plus 5, that is 25. Let us go to the fourth example. If in any problem we are writing PTR1 greater than PTR2, it will check the memory address stored in PTR1 and check whether it is greater than that address which is stored in PTR2. This comparison only makes sense if PTR1 and PTR2 point to elements of the same array. For example, here we have an array which has 3 elements here, 1, 2, 3. So ARR 0 is 1, ARR 1 is 2, ARR 2 is 3. So when we are writing star PTR1 equal to ampersand ARR 2, what is the meaning of that? The address of ARR 2 will be stored in PTR1. The same case is there with PTR2 also. So when we are comparing PTR1 and PTR2, what are we comparing actually? We all know that array elements are stored in contiguous memory location. That is, the memory locations are one after the other. So if we are telling PTR2, obviously the address is bigger, right? Why? Because PTR1 is actually the address of ARR2. So ARR2 should lie later as compared to ARR0, right? ARR0 comes first, then in the next memory location ARR1 will be stored, in the next memory location ARR2 will be stored. So obviously the address, okay, of ARR2 will be greater than the address of ARR0. So this condition is true. That's why this line will be printed, which is inside the if. Let us see another example. Here we wrote PTR1 not equal to PTR2. So we will just check that whether the addresses which are stored in both the pointer variables are not equal. Okay. For example, here PTR1 stores the address of A, PTR2 stores the address of B. Obviously, they are not equal to each other, and hence this condition of if is true, and the line following will be printed. At the end, students, let me tell you a few invalid or pointer operations which you should avoid. Two pointers cannot be added because it does not make any sense, because you are actually adding two memory addresses here. The same goes for multiplication and division also. So please note here that subtraction of pointer variables is allowed, but that is a complicated process which we are avoiding for the time being. Thank you, students.